series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the continuity of the previous unit, that is Concepts of GIS, under the subject Geographical Information System for the students of 3rd year 5th semester. At the previous class, we have seen what is GIS, what are the basic definitions that are involved under GIS, and what is a map, what the history involved in this, and what will happen and how it could be featured. Today we'll see in a detailed manner what is a scale map, what will happen in projection, and what is a coordinate system. Okay, so the scale map is nothing but it is defined in spatial relationships. What we have to do in the sense, while mapping a scale, what we have to do here is we have to consider the distance on a map to distance on the ground. So this is how we can convert them into a scale which is suitable for a map. There are two kinds of map scales, that is verbal, representative fraction, and the graphic bar scales. It indicates the level of detail and spatial extent. That is why these kinds of maps are very important. For example, 1 is to 1000 shows that 1 is to 10,000 shows a global pattern. So this is how the map scales have been converted. The map scales could be converted into two kinds. One is a small scale map and the other one is a large scale map. Small scale map will always show you a larger area with less detail. So here I have shown you at the drawing, which is ideal for climate modeling or national planning. So the data resolution is very low, as you guys can see here at the picture. But similarly, as you guys can see here at the large scale maps, it will show you minute details for the smaller areas. For example, if I have to use them for city planning and property boundaries, these kinds of large scale maps could be used. The data resolution for the large scale maps is very high while compared to that of the small scale maps. The projections that are used at the maps are the flattening of the earth surface. That means that what I have to do here is I have to transform the earth's 3D curved surface to a 2D plan. So why do I have to convert? In the sense, a sphere cannot be perfectly flattened without distortion. Here I like to quote you that at the surveying I have said that we have to consider that earth surface is plane, because we can't measure the distance while considering it as a circular manner. So similarly here also I can't perfectly flatten without distortion. So what challenges will I face here? While I'm converting these kinds of maps, I'll introduce some distortions like shape, area, distance, or direction. So that distance or shape or area will may be in slight difference while compared to that of the original level. So what we will do here is we will always use a conceptual model, that is cylindrical, conic, and the planar, which is nothing but azimuthal surface for the projection types. The common types of the map projections are cylindrical, conical, and azimuthal, as I have shown here. Cylindrical is always called as cynical, and azimuthal will be called as azistal and the azistial. So the cylindrical is usually considering the Mercator projection. As I have said at the previous class, there are two kinds of projection. One is a Mercator and the other one will involve your Albers area. So the Mercator projection is usually used for navigation purposes, which are really good. It will preserve the shape, distorts the area near the poles. But at the conical areas, the Albers equal area and the Lambert conformal conic will be considered. So it is usually used at the mid latitudes, as I have shown here at the second drawing. So at the mid latitudes, it is very best, and also it will help us to preserve the area and the shape very accurately. As you guys can see here, it is not possible for us to preserve the shape and the area. But if we consider this conic thing, it will help us to preserve them. Similarly, at the azimuthal or the planar surface, it is used for stereographic and normic. That means that it is ideal for the polar regions either at the North Pole or at the South Pole. So at the polar regions, in the sense wherever a higher degree is available, then it will help us to preserve the direction from the center point. So this is how the map projections plays a major role, and this will be the uses of them. Usually, the distortions and selections will be considered according to a property like shape, area, distance, and the directions. So, these kinds of properties will be affected by the projections. So, in order to compromise those, I have to consider the compromise projections that has been tried by Robinson and Winkle Triple. What they tried, in the sense, they tried to balance the multiple distortions, and they offered a more visually appealing global representation. So this is how we can collect a very good data with the help of map projections. The major impact of these kinds of projections will lead to inaccurate measurements. For example, if I'm trying to calculate a land area at the US census, it often uses Albers equal area due to its area accuracy, but it will not happen anywhere, because only US census maps will be used by the US people, but for us we won't go for that kinds of map projection or the distortion selection. We will select the maps that are suitable for us. So there are main things that we have to consider for locating the features very precisely. What we have to do, in the sense, for a unique reference locations on Earth, we have to identify a coordinate system for the purpose of providing us a common language for a spatial data across the data sets. It includes the datum, prime meridian, and also it will include the units of measure. So this is what which we have to be well known about locating these kinds of features in a very minute manner. So these geographical coordinate system is the main system which helps us to point out the latitude and longitude in the basis that it will use the angular units. That means that it will use degrees on a spheroidal and ellipsoid. So the key datums that are used under this is WGS84, which is a global for GPS, and NAD83 for North America. And the next coordinate system that is available is projected coordinated system, and this coordinate system is suitable for planar coordinates. At the previous one, it will consider your degree, that is latitude and longitude, but here we have to consider that the surface is very flat, that is it is linearly available at in units, that is meters or feet in a 2D surface. So the US specific zones follow a state boundaries along with a high accuracy for local surveys. So the advantage is it is direct measurement of distance and area within the zone, and it is easier for just calculations. So what I have like to conclude here is, here we have seen what is data acquisition, how the accuracy is very much related, and how the incorrectness could be detailed, and we can convert these kinds of projections into a surface coordinate system defining the location. So this is what I have prepared for today's class. See you at the next class. Thank you.